We now will be looking at the ASCII table, all right, and for every character that you type on your keyboard, okay, on your keyboard, for every keystroke, okay, keystroke, there is a mapping to this table, all right. There's a mapping, and this is the character that you type, and there is a value associated with that. Let's say you type letter B, uppercase B, there's a value in here, whatever that value is, okay, and that is what the CPU sees it. CPU, that's what we store in the RAM, all right. CPU sees it. So when you type any letter, any digits, any special characters, all right, for everything that you type on the keyboard as a mapping. So this mapping of keystrokes to value, all right, is stored in this table called ASCII table. So let's see some of the important letters, okay. If you go back to your module and you see the one on the red as this ASCII value, and the character that you type sometimes, for instance, the very first value is null. You see that 0 means null. So what does it mean? That means a value 0 is actually, there's no null character, all right. And you will use this in string operations in C language, for string operations, okay. We will go over this when we talk about strings. The string operations predominantly deal with null values, okay. And if you go back and look at, for instance, here digits start from 48 to 57, all right. So what does it mean again? That means letters, the digit 0 as an ASCII value of 48, 1 is 49. So right, let's say, let me erase this a little bit. So if you say 0, digit 0 as 48, 1, 49, it goes on, all right, it goes on. And if you go to other special characters, 60 is less than symbol, 61 is equal, 62 is greater than, greater. So we have all those values. The notable values, if you see a 65 as uppercase A for apple, 66 B, uppercase B. So all the uppercase letters start from 65. See that? 65 all the way to 90. So if you go back to our stuff, let me erase a little bit here. Now that we know keyboards, we don't need this here, okay. So 65 onwards to 90 is A to Z, uppercase. These are all uppercase, okay. And let's look at the lowercase. It starts from 97. From 97 all the way up to 120, I think it's 22, I think. All right. So you have all that, lowercase a to z. It starts from 97 to 122. So these are the key values that you might want to know all the time. All right. Now, let me erase this. So this CPU only stores numbers. We know that. Numbers. I'm sorry, here it's not good. Oops. Numbers, right? But we as humans or the keyboard, we only deal with letters A to Z, right? 0 to 9, all the special characters we have, right? And so how do we map it? We saw the mapping is the ASCII, right? And it's all numbers here. Even though they are stored in binary, let's still deal with numbers for now. Okay, decimal system. So how do we print back and forth? Let's say you have the number. That's in the RAM, in the CPU or the RAM memory, right? And sometimes we may want to print the letters, and sometimes we want to print the numbers, right? Numbers. So we will look into this, how we print the numbers, all right, into letters or the numbers. In C language, so that is what we are going to do now, okay? We are going to take a number that's stored in the memory location, numbers stored in memory. We are going to print them as is in decimal, okay? Or we'll print them characters. All right. So let's write a simple example. Okay. Here it is. All right. So I think I killed my stuff. Let me reopen it. All right. So you probably won't see this. So let me make it bigger. All right. So let me take a simple get char 1.c or print char.c. All right. So I have the standard template I use it. Main. All right. So char is a definition, a data variable type. Ch is the variable. Ch, now we say printf, enter a character. All right. So we store that in the variable ch. So whatever the user typed will store it in variable called ch. Get char will get a character from the keyboard, from the user. Okay. Get a character from the keyboard. All right. So we will print in numbers. The way we print that in number is %d. Okay, so this is where, let's go back here. So if you have a character, okay, to print as a character, you have to use %c as a character if you want to print as a character. And if you want to print as a number, because that's what the CPU stores, right? You have to print as %d. So we will print both forms, okay? Okay. The number stored is that the character stored is %c. So if you look at it, the same variable value can be printed either as a number or as a character. So as a number is what actually stored in the CPU, in the memory. Okay, so we will print this. Okay, there are no errors. So if you want to look at the file, cat is a command. Okay, this is exactly what we printed. So to run that program, enter a character. Let's say I enter uppercase G. So the number stored is 71. And the character as is G. Okay. So what is 71? If you go back here, 71. You see that? G. Alright. Similarly, I can do it one more time. Let's say lowercase s for Sam is 115. 115. So what is 115? Is S. You see that? So that is how you print characters or numbers, all right, using getChar. Now I'm going to show you another example. I'm going to copy that file, print char, to operate on chars.c. Okay, so now we will be looking at how to, I'm going to erase this. Okay, the next is how to operate on characters. The very first thing is we defined char, ch. Or let me do one thing. Okay, let's go with this. Okay, ch. So ch, if you want to assign a number, we said 101 or 107, right? 107. Is it what we saw? 107? 115. Let's take 115. Okay. 115. 115. If you store, now you are storing a number now, which is equivalent to S. And in C language, characters, when you hard code characters, you need to put a single code. Okay, let me show it again. This is all, or we can write as ch equal to lowercase. This is lowercase. Okay, Yes. So that's one way of representation. Single quote. Okay. Of assigning a character to a variable. And we can also do this ch equal, let's say, uppercase G plus 4. We can also do that. So uppercase G is what? 71. Isn't that what we saw? 71. So 71 plus 4 is 75. So 75 will fetch you number k. That's what we are going to do now. Okay. Operate. I'm going to do here ch equal to ch plus 4. Is it what we said? 4 here? 4. Yeah, okay, 4. So we are going to do that, and we are going to print the character. All right, very simple, right? Let's do that. All right. G. You got K. Got it, right? You see that? Let's go ahead and we can also do here, let's say ch equal, let's say char. I define another variable ch1. I can do ch1 equal to ch minus 2. I can do that too. So these are very valid expressions in character. Valid. What's going on here? Valid. All right. This is invalid. Single quote, that's invalid because we have two characters. That's wrong. And this is also invalid. Okay. Because if a lowercase c is what, 99. So there is no statement called 99 equal to. We can never do that, right? So you have to be careful with these statements. Okay. So that is our very simple operations. Basically, we can assign characters to a variable using single quote. We can assign a character to another character variable. All right. And the key is you need to know the difference between a single quote and a double quote. We will talk about double quote when we come to strings. Okay. Strings use double quotes. And single quote is a character. And these are called character arithmetic. Okay. You see how we do that? All right, that's all for this. Thank you very much. And I will upload these two programs for you guys. Thank you.